Okay, let's go ahead and draw out these structures. So the pentanamine, it's gonna have what? What do I need with this? I need some carbons, 5 of them. And then since nothing was written, where's the amine structure? Okay. And then N-ethyl hexanamine. All right, so I'm going to throw up 6 carbons. And then a nitrogen. And then N-ethyl means I've got 2 more carbon, a carbon chain of 2 coming off that nitrogen, and then I need another hydrogen. Are we good with that?
Can you put it off like the top of the end?
Doesn't matter.
It doesn't matter? Okay.
And then this one here would be a primary, and this one here would be a secondary since it's got 2 carbons attached to it. Okay, so NN methyl sec-butyl 4-chloral heptaneamine. That's a mouthful. So 7. So 2, 3, 4, 5, 6, 7. So there's 7 carbons. I'm going to take those 7 carbons and I'm going to attach them to a nitrogen. And 1, 2, 3, 4, and that'll give me my spot for my chloro. And then I need a methyl group. So there's a methyl group coming off my nitrogen, and then a sec-butyl. Are we good with that? So this NN, that's, every time you see an N, capital M written, that means it's another thing that the nitrogen is attached to. So since there's 2 N's, it's already attached to something, then there's 2 other carbons attached because it says NN there. So then what kind of classification am I going to give this nitrogen? Tertiary? Okay. And then hexanamine. So 2, 3, 4, 5, 6. And then it's 3 amino. 1, 2, I'll go from this side. NH2. Does that look good? All right. And this guy is primary. Name the following. Okay, so what's the IUPAC nomenclature for this one? First one, number 2. Any name we want? What kind of molecule is it? These guys are amides. Okay, and so I've got 3 carbons there. So what do you want to call it? Propane amide? All right.
All right.
I don't know why that thing's moving. And this is primary, right? Only 1 carbon connected to it. The next one is, are we okay with me saying that this is tertiary? There's just no hydrogens attached to it at all. It's just a bunch of carbons. So since it's multiple carbons, you're going to have N's. And since it's 3 total, it'll be NN. The longest carbon chain is pent, right? So it's pentanamine. And then it's N-ethyl and N-methyl. Are we okay with that? Where's the what? So 2 carbons there, 1 carbon there. Oh, I'm sorry, 4 carbons, not 5. 4 carbons there. So
Three ends now.
no, there will never be 3 ends.
There will never be three ends.
No,
Okay.
never be 3 ends.
I put you first, as a two first.
Yeah, but the end
That's the
is
root.
not
The
as-
butane's the root. Are we okay with that? NN ethyl methyl butaneamide? I'm sorry, amine. Amine. So it's an amine because there's a nitrogen there not attached to a carbonyl carbon. It's butane because the longest carbon chain is 4. And then attached to the nitrogen, I also have a 2 carbon chain and a 1 carbon chain.
You ever say N ethyl and methyl?
Never happens.
Okay, it's always N and N.
Yeah.
Okay.
Yeah. I guess that is different than the 1-2 kind of deal, but yeah. It's always NN, or just N. Okay, and this guy here, we okay with me saying this is secondary? Actually, the way I've got these drawn up, you don't really know that, do you?
Yeah, I thought it was,
Well, actually, I suppose you do.
Okay.
How do you know that this is not a hydrogen?
Because it won't be there if it was.
Because the rest of it's drawn as line structure, right? So it must all be, all the lines must all be carbons.
Yeah.
And how do you know that that's a hydrogen and not a carbon? Because I drew a carbon right there, so if there was a carbon right there, I would have drawn it. So then what's this here? Hydrogen.
Gotcha.
So secondary, because there's 2 carbons attached to that nitrogen. And it's an amide. And so I've got 2 carbons and then the 1, so N methyl, ethane, amide.
Oh, I forgot the N in
Mm. And the last one?
there. This one,
Butene diamine?
dibutamine. And then.
Butane diamine. Okay. Anything else? Yeah. 1.
Oh, 2.
It was really hard to do. What's another way we could name it?
Diamine, butane.
I put dibutamine.
1,4-diamino butane. We good with that? And I've got 2 primaries here, right? All right. For number 3 here, in the notes it talked about the making of an amide is between a carboxylic acid and an amine. And so this guy gets broken right here. That's the break point. This is half the molecule and that's half the molecule. So the carboxylic acid side is the left side. And so I'm going to need a CH3, C double bond O, OH. So there's the carboxylic acid. And then the amine is in, let's do that. So when you go from the left side over to the right side, what disappears off the carboxylic acid? We okay with saying that the OH is what's gone? So this part right here is gone. And then how about on the amine side? One of the hydrogens disappears. Actually, that's the other one that disappeared.
There it's gone.
Say that hydrogen is the one that disappears. And so what's that leave us with? And that makes sense because nature likes to make water molecules all the time. This one is exceedingly simple. It's hydrochloric acid, right? And CH3, CH2, CH2, NH, CH2, CH2. That's a terrible CH2. Why is the hydrochloric acid making a compound here?
Because of the two electrons, the nitrogen has to be
So the nitrogen is acting like a
base.
base. Okay, so the nitrogen acts like a base. The hydrogen from the hydrochloric acid is my acid. So when this compound is formed, this H comes off of here and attaches itself there, right? And then if I were to dry this compound out, this is what I would have left. Why might you have seen something like that before? Has anybody ever seen hydrochloric acid written on something or other? Say,
That's not what you sketch glass with, is it? No.
I'm pretty sure. Learn about our products. I just want to know about the one product. Not that one. That product doesn't work. Maybe it's just that one. All right, there we go. What does it say? Pseudoephedrine hydrochloric acid, right?
Oh, yes.
Why? Does that thing that I have highlighted green, does that look like it would like to mess around in water?
No.
It's really, really non-polar, right?
Mm-hmm.
So what did who makes this stuff?
Very like it.
Maybe.
I don't know.
McNeil.
No, I'm pretty sure they're the people who came up with this little effective advertisement. I don't know. That's irksome. Okay, well, whoever came up with this, the problem was this, since we were talking about amines, this amine here will do the things that we wanted to do, which is shrink nasal membranes so that you're not draining fluid out of your nose. Except I can't get that thing into the body. So what did they do to it? They turned it into a what? They turned it into a salt. So they reacted it with hydrochloric acid, and here's a base, and here's an acid, and an acid and base make what? A salt. So there's my salt. So the moment this touches water, what does the chlorine do? Leaves. And so now I got this chloride off doing its thing, and then I got this thing that's a charged particle, and so water can attack it. So this gets disassembled and can flow through the bloodstream because they turn it into an acid. So if you're looking at a drug and it says hydrochloric acid on it, They only put it on there to make it a salt, so that it would be solubilized and make it through the bloodstream. They wouldn't have had to do that if there were more what on this? OHs or Ns. If there are more Ns or OHs, because Ns and Os have bare electrons on them for water molecules to interact with. What is it about the amines that make them basic?
First one.
The two electrons with the nitrogen. that it
Those
dominates.
two lone pairs. So the nitrogen is going to make 3 bonds, and so those other 3 electrons are being used to make bonds, but then it's got that lone pair of electrons. And Lewis's definition of a base? And they've got that lone pair of electrons to do that. Okay.